In the last couple of videos, we've looked at analysis of variance and the Kruskal-Wallis test to compare the means or the medians for 3 or more treatment groups. And we ended up concluding for the circadian rhythm experiment, when we did the analysis of variance F-test, the conclusion was that at least one treatment mean was different from the others. But what we haven't addressed yet is which treatment means are different from each other. And so that's what we're going to tackle in this video. We have to be careful when we are thinking about this kind of situation where we've got 3 or more treatment groups, because there's potentially many different comparisons that we could make. So, for example, we could compare the population treatment mean for the eyes group compared with the knee group. We could look at the eyes group compared with the control group, and we could look at the knee group with the control group. And so the reason we have to be careful is because every time we make a comparison between different levels, whether we're doing a test or calculating a confidence interval, there is some underlying uncertainty in the result that we get because of sampling variation. And so, because there's some uncertainty associated with every piece of, or every comparison that we do, the more comparisons we do, we increase the possibility that we are making some kind of mistake, either in our decision if we're doing a hypothesis test, or in our interval if we're calculating a confidence interval. And so this issue is known as multiple comparisons. So it's something that applies anytime you have 3 or more levels for a categorical variable. You have to keep in mind this issue of multiple comparisons. So there's a couple of ways of addressing this. So one way is if, when you're planning your experiment or planning your study, you've got a categorical variable that's got, let's say, 3 levels, but your primary interest is in the comparison between just 2 of the levels, then you can do what's known as a planned comparison between those 2 levels. And as long as you focus your attention on that planned comparison, then that's one way to kind of mitigate this issue of multiple comparisons, because now you're not doing multiple comparisons, you're just doing a single planned comparison. And so that's what I'm going to talk about in this video. The other approach is if you come into the experiment or when you're planning your study and you don't really have a specific interest in comparing 2 of the levels. Your interest is broader, and you're interested in comparing all the different pairs of levels. And so then you do have to get into worrying about multiple comparisons. And so that type of comparison is called an unplanned comparison. And so we'll talk about that in the next video. So to go back to planned comparisons, so that's what I'll talk about for the remainder of this video. So in this particular context, the researchers they were really interested in comparing the knee treatment to the controls, because I think they were kind of skeptical that shining a light on the back of someone's knee would have any impact on their circadian rhythm. It didn't seem to make much biological sense, and so that's what their interest was, and that was determined before they started even looking at any data. They designed their study and they said, we're going to look at the comparison between the knee treatment and the control treatment and see if there's anything going on there. So it was a planned comparison, and it's the only comparison that we're going to look at now. So we've already analyzed this data. Maybe I'll just pull up the ANOVA table again so we can see it. So we ended up with an F statistic of 7.29, a p-value of 0.0045. That was less than our significance level of 0.05, and so we rejected the null hypothesis in favor of the alternative, and the alternative hypothesis stated that at least one treatment mean is different from the others. So now we're going to do our planned comparison, and so we're going to look at the difference between the knee treatment group and the control group. So we're going to use this function here, em means, and it's in this package here called em means. So we can find out more about that here. So this tells you all about the function that we're going to use. And so we'll run this code. And then we're going to use this contrast function. So let's have a look at the contrast function. So this is also in the em means package, and again, this tells you all the different things that it's able to do. And in particular, this argument here, adjust, tells us the adjustment method. And so in the case of a planned comparison, we want to set the adjustment method to none. So if we do that, and then we're going to use one final function, the confint function. Okay, it'll give us all of the comparisons, but we're just doing a single planned comparison between knee and control. So this is the piece of the output that we want to look at. Again, we can do these calculations by hand if we wanted to, and it can be worthwhile doing that the first couple of times you apply this technique, because it does give you a little more insight into what's going on. But in practice, once you're comfortable with what's going on, then you can just do this shortcut method here that we just went through and just look at the output without having to calculate by hand all these different numbers. So the main part of the output that I want to focus on is this confidence interval here. So this is the 95% confidence interval for the difference between the population means for the knee group and the control group. It's between minus 0.79 and 0.736. And so 0 is it's inside that interval. It's pretty close to the middle of that interval actually. the middle of the interval is minus 0.027. So 0 is very close to the middle of that interval. So that what that's telling us is that the observed mean phase shifts of the control and the knee treatment are consistent with no real difference in the population means. Or if there is a difference, it's very, very modest. And that supports what we saw in the graph that we drew, in the strip chart that we drew. In the sample, not a whole lot of difference between the knee group and the control group. And this planned comparison, when we're looking at the confidence interval, tells us, supports that conclusion. So that's a planned comparison that we can do between two of the levels after we've done an analysis of variance f-test. In the next video we'll talk about unplanned comparisons and see how those work in this context.